Alright, welcome back to part 2 of our How to Draw a Pie Chart in SwiftUI series. In this part we will finally get to the programming. So let's get straight into it. Make sure you open up Xcode, create a new project, and I'm going to choose app, but for you it could be also called single view app. The reason why it's called app for me is that I'm using the latest beta version. Let's continue. I'm going to call this one pie chart. Make sure that the language is set to Swift and the interface set to SwiftUI. Continue by pressing next, save it somewhere you like. Now once you're inside of Xcode, choose content view. Also choose the iPhone 11 simulator if you can. And then also make sure the automatic preview is working for you so you can see the result. Alright, the first thing we are going to do is create the piece of pie shape that we were talking about in part 1 of the series. So let's do that. Now there's a slight difference in how we are going to implement this. We are going to first create some properties to keep track of the start and end degree. And the way we do it is by simply defining it as follows. They both are going to be of type double, like so. And then we can implement the function that is required in order for us to conform to the shape protocol, which is this path function. Actually, let's move this up a bit. All right. Okay, so in here we return the path, and we also have access to the path inside of the closure, like so. So the first thing we are going to do is move to the center of the frame, similarly to how we discussed it in part 1 of the series. So let's do that. Center is going to be a CG point, and it's going to be the mid X for the X coordinate and the mid Y for the Y coordinate. Now let's move to the center. The way we do it is by simply calling move to, like so. And lastly, let's add the arc. Let's pass it the center. The radius is going to be half of the frame's width. The start angle is the one we defined up here. Similarly, we also pass in the end degree, and also make sure that clockwise is set to false. Lastly, we also want to make sure that we close the subpath, like so. There's still some error in here. Oh, it turns out that the angle, the start and end angle return angles, and we're just passing in a double, so we can simply solve it by angle with degrees, and here we can pass in our double. Similarly, we also have to do it for the end degree. I'm just going to copy this. All right. Now let's check if it really does what we expect it to do. We are simply going to call this one in the content view, like so. And here we pass in the start and end degree. I'm going to say 0 and 90. And if we try to resume again, we should be able to see our piece of pie. So I could also change this to 180. It works just as we wanted. Now one way to build the pie chart is by simply creating multiple of these arcs directly inside of this struct. I personally think the best way to do it is to simply stack these pieces of pies inside of a Z stack. And instead of just creating all these pieces inside of this function, we are going to create a view that again contains a Z stack and can create multiple of these pieces as at once. So let me show you what I mean. Let's start by creating a struct called pie chart. It's going to be of type view. Let's make sure it has also a body. Now in here we are going to return a Z stack. And inside of that Z stack, we are going to try to stack these pie pieces. So let's start by creating the first one. Let's do the similar example. We start at 0 and in degree 90. And then let's also give it a color. Actually, also make sure that you call this view inside of the content view so we can see it. Let's resume. All right, here's our 90 degree. And now let's just copy it one more time and give it a color of blue. Now, since the start degree and end degree are the same, it's just basically on top of it. But here's what we have to do. We have to make sure that we start where the previous pi ended. So we start at 90 degrees and then we can choose any number we want. Let's say 180. And as you can see, it fills up perfectly the pie chart for us. Now, obviously, we're not going to do it like this, like writing these line by line. What we are going to do instead is we're going to use a Viewmodel. But before we get to the part of creating the Viewmodel, it would be nice to have some models to represent the type of content we are going to represent with our pie chart. Now, in this case, I chose the example of assets. So for example, you could use it to describe how much your customers are invested in specific assets like stocks, bonds, or real estate. So let's start by creating the models for this. As always, usually you have these in separate files, but in this case, I'm going to put them all into the same file so it's easier for you to follow. So we're going to separate these from the views. And I will simply start by creating an enum. And that enum is going to keep track of all the asset types we can have. So it could be an equity, cash, bond, or real estate. Now that we have this enum, let's also create an asset allocation struct that can keep track of how much percentage we have in each of these assets. So let's do that. Inside of here, we obviously want to keep track of the type of assets. So simply going to say asset is of type asset. We also have to keep track how much this allocation is in terms of percentage. Also a description that we could use later for labeling these. And lastly, I would also like to keep track of the color, like so. I think now we are ready to create the view model. So let's also separate this. Let's call this view model pie chart view model. Let's also make that class final. We also want to make sure that it conforms to the observable object, because that way we can update the view based on changes that can happen here. So for that, we have to make sure that we have the @published variable, data, and the data will be an array of our asset allocation, right? Like so. Now for this, I already created some dummy data that I'm just going to paste in. So here we basically have one asset location for each asset. For cash, we want to have 10%. For equity, we want 40%. For bond, we want 30% of the pie chart. And for real estate, we want 20%. Also, you can see I have defined some colors, but you could also use something like these default colors. If you want to know how to define these colors yourself, it's quite easy. All you have to do is go into this assets folder, and then in here you could simply create a new color like so. And if you want to change the hex color of it, you can also do it by changing the input method to 8-bit, and here you can pass the hex value for that color. So let's go back. Now that we have the data and our Viewmodel, we can use it in the pie chart. So in here I'm going to create an observed object. And this is going to be our Viewmodel that we just created. And then inside of the C stack, we can access the Viewmodel's data. And then we can create a for each loop where we simply create these pieces. So let's do that. Let's start with the for each loop. Now we are going to pass it a range. We will say it will start at 0 and end where the Viewmodel.data count ends. Now in here we will get back the index. The index represents the location inside of this array. And with that we can do our calculations. So let's start by accessing the current data. So our current data is the Viewmodel.data at the index that we got passed in. Now here's the tricky part. What we have to do now is we have to kind of keep track of the last degrees. So when we draw the first piece of pie, we start at 0 degree, right? But when we draw the second one, we want to draw it where the first piece of pie basically stopped. So basically in this case it stopped at 90, and we start here for the blue one. And if we had a purple one, we don't start here and we don't start here. Instead we start right here. And to do that we have to kind of sum up all these percentages up to the point where we are at the index. And the way we are going to do this is we are going to access the array, but we want to have a limited version of this array. So we only want to have the first 2 elements or the first 3 elements depending on which one we are drawing. And to do that there's a nice handy function that you can use on arrays, and it's called Prefix. And what Prefix does is basically assume you have an array like this and you want to have prefix 2. What it does is it takes the first 2 elements. Now initially when our index is 0, it's obviously going to be the empty array, and if we take the sum of this empty array it's going to be 0, and this is perfectly fine because for the first one obviously it's going to start at 0 degree. So let's do that. We want the prefix. Oh, I'm sorry, we have to create a new variable. We want to keep track of the last degree. So we start similarly, we say Viewmodel.data, but we are only interested in index many elements of the array, and the others can be neglected. So once we have these, what we basically have now is an array of asset allocations. But what we really want is not the array of the asset allocation, but we want the array of our percentages, which are of type double, and kind of sum up to the point where we are interested in. And we can do that by simply calling a map function. So the map function allows us to transform the array elements. So we're taking each of these elements and we are accessing the percentage. Now, if you look up what last degree is, you will see it is an array of the doubles. So now that we have the doubles, we have to basically add them up. And there's another handy function we can use, and it's called reduce. And we simply say start at 0 and add up all of these elements till you reach the end of the array. So now we have a double which represents the percentage, but to get the degree we have to also multiply the percentage by 360 degrees, which represents a full circle. Now we also have to keep track of the current end degree. So let's do that in here. And it's going to be simply current data dot percentage times 360 degrees. Now we are ready to create our Z-stack, and the way we do that is as follows. Inside of this Z-stack, we are going to simply say piece of pie our piece of pie needs a start and end degree. Our start degree is obviously going to be the last degree, and our end degree is going to be the last degree plus the current end degree, right? All right, now let's see what we have so far. Let me resume this. Okay, it seems like we have our pie chart, but you can't really see anything because we didn't set a color yet. So let's do that. And the color is going to be basically what we get passed at the specific index of our data array. So we simply say current data dot color. Oh, and here you can directly see that we have a result. Let's make sure that it's really what we want to see. So cash should be gray and should be 10%. That looks right. And the biggest asset here should be the equity, which has a blue color. Perfect. All right, so there's still one thing we have to do. I would also like to have some labels so you can easily tell which piece belongs to which asset. And to do that, we are going to create a text inside of that Z-stack, like so. And we are going to pass the current description that we get from the array. So it's the current data.description. And if you do so, they will all be stacked. And remember, in part 1 of the series, we talked about how to position these labels and the trigonometry rules that we have to use for them. And this is basically what we're also going to do in here. Now, to do this trigonometry math, we are going to declare a new function after the body, and I will simply call it getLabelCoordinate. Now, to get the label coordinate, we have to know where the text is right now and how much space it got available. And for that, we are going to use a geometry reader. If you don't know what a geometry reader is, there's also a video on that. Make sure you watch it and you will understand the concept behind it. So let's start by simply passing what we get from the geometry reader later on, and it's going to be a CG size, and we will say for degree. Our degree is going to be of type double, and then we expect it to return the position of our label, so a CG point. So let's start with some basic calculation. Let's first calculate the center. So the center is going to be the geo size dot width divided by 2. Similarly, the y coordinate is going to be geo size dot height divided by 2. So now we know the center. Let's also calculate the radius. Now in this case, I don't want it to have the label right on the side. We are going to do a small optimization. We are going to reduce the radius a bit. So what I'm going to do is I'm going to say the radius is going to be equal to the geo size dot width divided by 3 instead of 2. That way it's much closer to the center of the circle. Next, we are going to calculate the y and x coordinate using the trigonometry rules we learned. So we say the y coordinate is going to be equal to the radius times sine. Remember, sine expects a radian value, not a degree value. So we make sure that we take the degree and multiply it with pi over 180 to convert it to radian. Also, we have to make sure that we pass CG floats, because the degree we are getting in here is a double and not a CG float. All right, we have to do the similar calculation for the x coordinates. So I will first just copy this one. The difference here is going to be that we are using the cosine, and otherwise it's going to be identical. Now that we have the x coordinate and y coordinate, we can return them as a CG point as follows. Now, since we want the x and y coordinate to be relative to the position of the label that it's right now in the z stack, we also have to make sure that we use the center x and center y and add them to the x and y coordinate. So let's do that. All right. So now we can start using this function, and to do that, let's start by creating the geometry reader for the text first. So in here, we will have our text wrapped in, and the geometry reader is also going to give us this geometry proxy. And this can be used later to calculate this geo size. But let's first start by using some modifiers. I would like to use some custom font here. I will simply say custom. I'm going to use the font Avenir with a size of 20, like so. And then I will also give it a foreground color and make it white. And then here comes the important part. We're going to calculate the position of this label. We will simply call them position modifier. And here we will call the get label coordinate for the geometry size that we are getting. So from the geometry proxy, there is this size which represents the size of the container view. And we're going to pass this one in, and also we have to pass in the degree we are interested in, and that is going to be the last degree plus the current end degree. Now if we would do that, it would be right on the edge, like here, but I really wanted to have it more to the center, and to do that I have to make sure that I divide this current end degree by 2. And let's see what we got so far. Perfect. As you can see, the labeling works just as we wanted. It's not right here, it's exactly in the center, and it looks really nice. Now you can also play around a bit with these constants, like here where I'm dividing it by 2, or where I'm taking 1/3 of the radius. If you, for example, take half of the radius, you will see it will be much more off. And with this, it's much closer to the circle. So I hope this was helpful. Make sure you subscribe to the channel so you get notified when new content arrives, and I will see you in the next tutorial.